Hi everyone. I'm going to walk you through the final part of the Unit 4 project. So this is the part that you're going to do during final exam week. We started Unit 4 by looking at phylogenetic trees as a way to measure how close sequences collected on two separate dates were to the original reference sequence for SARS-CoV-2 that was collected in December 2019, and how close they were to a more recent version of the virus, something that matched a primer that identifies B117 variants. So how close, if the tree is rooted to the original reference genome, and how close are the sequences to each other if they're rooted to B117. You can see this is a map of data that I had from last year. The data set was partly from Utah, partly from Spain, all from March of last year. And three of them matched B117 using the primer set, and most of them were not a match. So I did edge coloring by if it was a match, and I did tree leaf coloring by the sample location. Now what we want to be able to do is look more broadly. Our first couple phylogenetic trees give us some interesting information, but a very small number of genomes. We really are limited by how many genomes we can show in a tree. Although you can look at all of the next strain data on a single tree, it can be a little bit overwhelming. We can do that by looking at variant proportions. So instead of looking at individual genomes, look at the pooled data and figure out at any given time, at any given date, what percentage of the COVID-19 samples and swabs that are sequenced are B117 or other variants. You see the CDC has a summary by date. Starting in January 16th of this year, they started to track this and looking at what is the proportion across the country, and also what is the proportion in each HSS region, or we can even switch to looking at each state. So if we scroll down, you can see the table that shows the percent of each variant in every state. I'm going to have you guys create a map that looks a lot like this graph with pie charts, but you'll do it for 5 states that you select. Try to pick states that are not right next to each other so that it's visually easy to see. And then only pay attention to the percentage of B117. Because that is the dominant variant in the United States right now, we want to be able to track its prevalence in 5 different locations. I've created this guide to show you step by step how to make the map. So the first thing you're going to do is load the libraries you need, maps and plot tricks, read in a spreadsheet of GPS positions for each state, and I've given you a website to look those up, and then use this CDC website to look up the percent variant at any given time. So when I made this map, this was on April 14th. Massachusetts was 29.4% and California was 15.9%. Now, just a little bit later on April 26th, Massachusetts has jumped up to 31.1% and California has jumped up to 17.8%. Once you have your percentages typed in and your GPS locations read in, you're ready to make the map. We're going to plot the state map with locations from the database. So there's a database that has like what pixels are going to be black on a map of the United States. You're going to plot the axes so you can see the latitude and longitude locations. Then you're going to graph points at each GPS longitude and latitude that corresponds to your states, and then change those circles, those points, to be pie charts. So we're going to put a floating pie chart in each of those locations, and you'll be able to have a really nice comparison very quickly between which of the states that you sample have a higher proportion of B117 compared to the other states. This is the final project in bioinformatics. I hope it's something that you think is an easier way to understand and digest the data than the table view. And once you've mastered this final type of plot, you are done for the semester. I hope you keep learning R. and let me know if you have any questions.